Welcome to the Explainer. Today we're asking, why design three different space worlds and not just one? I mean, with all our tech, you'd think we'd aim for just one perfect design, right? Well, the answer is that building in space is a journey, not a single destination. Each design is a step. Think of it like a temporary ship, then a town, and finally a new world. So the very first challenge is super simple. What can we actually build right now? And that brings us to the Stanford Torus. It's basically our starter home in space for 10,000 people. The ring shape is great because it handles the stress of spinning really, really well. The bottom line, we can build this today with the steel and aluminum we already have. All right, for the next two designs, we hit a major trade-off, the strongest shape versus the most land. First up, the Bernal Sphere, our industrial hub. It's the strongest shape for holding in air. Super efficient. But here's the wild part, the gravity changes. You'd feel normal at the equator, but float at the poles. So you get a great workshop in low G, but not much prime real estate to live on. For our real civilization, you need something different. Enter the O'Neill cylinder, the mega mansion for millions. The cylinder is a whole different ballgame. It gives you huge areas of flat land with normal gravity. And how do you get gravity in any of these? Simple. It's the good old washing machine spin cycle. So you see, it's not about which one is best. It's about having the right tool for the right job. And here's the final showdown. Each one has its own role, its own cost, and its own tech challenges. So if we're ever going to truly live in space, we have one massive problem we've got to solve. Out there, our bodies just aren't built for it. We float, our muscles atrophy, our bones get brittle. The one thing we take for granted every single day on Earth, gravity. Well, it's just not there. Right, so how do you build a down where there is no down? How do you actually construct entire worlds with solid ground for our feet? Well, the answer is kind of wild, and it's probably sitting in your laundry room right now. Just take a look at this. On the left, you've got a washing machine in its spin cycle. On the right, a gigantic space colony. And get this, they work on the exact same principle. Yep, that's it. The secret sauce to making artificial gravity is unbelievably simple. You just have to spin. It's such a simple, elegant fix for one of the gnarliest problems of space colonization. All right, gravity spin cycle, let's get into it. We're going to see exactly how this cosmic laundry machine works and how engineers have dreamed up three totally different kinds of worlds, all based on this one core idea. Okay, so the science here is called centrifugal force. As a habitat spins, everything and everyone inside gets pushed away from the center. It's this constant outward push that pins you to the inside wall. And boom, that wall is now your floor. You would literally be walking on the walls, and it would feel totally normal. The starter home. Okay, so how do you turn that spinning principle into an actual place to live? Let's take a tour of some future real estate, starting with the most practical model, the one we could pretty much build today. First up, meet the Stanford Torus. I want you to picture a huge bicycle tire in the sky, more than a mile across, spinning slowly about once every minute. This thing is designed to be our starter home in space for around 10,000 people. Basically a small town just hanging out in a stable spot between the Earth and the Moon. Now, living here comes with a pretty interesting trade-off. The big pro here? The gravity is consistent everywhere in the ring, which is fantastic for building a city. And maybe most importantly, we can build it with stuff we already have, like steel and aluminum. But the downside? Man, you look up and the sky is this tight, curved loop. It's kind of cramped, and you just don't get a ton of land. The efficient industrial globe. All right, next up is a design that is all about pure engineering efficiency. This one isn't just a home, it's more like a workshop. So this is the Bernal Sphere, and because it's a perfect sphere, it's the strongest shape you can possibly build to hold in air pressure. That makes it super efficient with materials. Think of it like the studio apartment of space habitats. Strong, compact, does the job. But here's where this thing gets really weird and cool. Full Earth-like gravity only exists right at the equator. If you start walking toward the poles, the closer you get to the center axis, the weaker gravity becomes. By the time you get to the tropics, you could probably jump 50 feet in the air. And right at the very poles, you'd be totally weightless. And you know what? Engineers don't see that as a problem. They see it as a huge opportunity. The best living space is at the equator, sure. But those low gravity zones become the perfect spot for all sorts of zero-G manufacturing, crazy science experiments, or you could invent some absolutely insane new sports. Imagine that. The mega mansion in space. Okay, so we've seen the starter home and the industrial hub. Now it's time for the final act, the absolute mega mansion. This is the ultimate dream of living in orbit, building a true world from the ground up. And here it is, the O'Neill cylinder. I mean, look at this thing. We're talking about a habitat that is 20 miles long and 5 miles wide. It's built to house millions of people. This isn't just the mega mansion, it's the whole dang country estate. The first amazing thing, you get miles and miles of perfectly flat land with the same gravity everywhere, just like back on Earth. It's so big, it can have its own weather. We're talking real clouds, real wind, even rain. And the view? Oh, the view. You look up and you see the other side of your world. Towns, forests, rivers, all curving up over your head. But there is a huge catch. Holding that much air inside while spinning that fast creates a huge amount of strain on the structure. A massive engineering headache they call the balloon problem. The whole thing just wants to tear itself apart. So to actually build one of these, we're going to need some kind of futuristic super materials that we haven't even invented yet. Okay, so let's do a quick recap of our 3 contenders. You've got the Torus, your affordable starter home with steady gravity. Then there's the Sphere, the super strong industrial workshop with that cool gravity gradient. And finally, the O'Neill cylinder, the breathtaking, wildly expensive new Earth with its own weather. You can see how each one plays a totally different role in how we might move out into the solar system. The rules of world building. All right, these designs are mind-blowing for sure, but out. And that really brings us back to the big question for you. As we think about actually going from just visiting space to living there, we have to make a choice. Do we start with the practical starter home, the Torus? Or do we build the industrial hub, the Sphere, to get our space economy going? Or do we shoot for the stars and start the generational project of building the new Earth, the cylinder? If it were up to you, which world would you build first?